Greetings, Panthers. Dr. Augustine. Today we're going to take a look at Chapter 6.2 Intro, Pressure, the Result of Molecular Collisions. And the main topic here is going to be about what pressure is and the most common, or some of the most common units of pressure. There are lots of different pressure units that one could have. And the major topics we're going to talk about is what pressure is, which is actually a force per area, several common pressure units, and some of the ways we use to measure them. So, let's start with what pressure is, and pressure, very simply, is a force per unit area. And gases exert a pressure on us because if we have a container that's filled with gases, those gases are actually constantly in motion. And when those things are moving, they hit the walls, they hit each other, but they also hit the walls of the gas, whatever the container is that it's held in. And these molecules are in motion, and we know that any sort of object in motion has some sort of kinetic energy, which is equal to 1/2 mv squared. So that kinetic energy gets imparted to the surface. Now, each individual gas molecule is not that much, but when you have 10 to the 23, 10 to the 24 gas molecules hitting against the surface, it starts to get to a measurable amount of force. So if we measure over some unit area the amount of force that we have, that is what pressure is. So the SI units would be, force is in units of newtons, and meters squared would be in with the area units. So pressure would be measured 1 Newton per meter squared, which is also given the symbol PA, 1 PA, which stands for 1 Pascal, named for Blaise Pascal. Unfortunately, 1 Newton per meter squared, or 1 Pascal, is a very, very small amount of energy, amount of pressure. So we don't typically do things in pascals. We often do them in kilopascals. In fact, the average air pressure exerted at sea level is over 100,000 pascals, 100,325 pascals to be exact, 101.3 kilopascals. Now, actually, in our class, we're not going to use pascals all that much either, because it is kind of a strange pressure unit. You might be familiar with PSI, pounds per square inch. If you fill up the air in your tires, that in the car, that's about 32, 34 PSI. If you have bike tires, depends on whether you have a mountain bike or a road bike, it might be 60, 70, 80, even over 100 PSI. And that's relative to what atmospheric pressure is. So that's above the atmospheric pressure. The more common unit that we encounter is in terms of mercury. So here's the experiment. You have a dish of mercury. You insert into that dish of mercury a glass tube, and the glass tube, you've evacuated all the air out, and what you've done is you've created a vacuum in that glass tube. So you've somehow sucked all the air out. You stick the tube into the vat of mercury. Please don't try this at home. Mercury is a toxic substance, and you really shouldn't be playing with vats of mercury. But if you drop this tube, evacuated tube, into a vat of mercury, a column of mercury will rise up in the tube, and this is actually drawn correctly. The meniscus goes in the other direction from what you're used to with a water meniscus, curves up. And what's the reason for this column of mercury pushing up out of this tube? Mercury is a very dense liquid. It has like 13 grams per centimeter cubed. So it takes an awful lot of force to push this up into this tube. And what the force is atmospheric pressure. The atmosphere is pushing down on the mercury outside of the tube, and that's forcing this column of mercury to go up into the vacuum. So another unit of measure that we can use is by measuring the height difference between the surface of the mercury and the top of the meniscus. And this unit would be in often millimeters of mercury, or it could also be in inches of mercury. Now, the standard value at sea level is 760 millimeters of mercury. So this is a common unit that we'll use, 760 millimeters of mercury. Is actually equal to this 101,325 pascals. And we also have a special name for that. We call that 1 atmosphere. So 1 atmosphere is the pressure, that's the average air pressure, which is measured at sea level. So typically it's about 1 atmosphere at sea level. As you go up in elevation, as you go to higher elevations, you would anticipate the pressure to be less because there's less gas molecules the higher and higher in elevation you are. So these are conversions we should know. 760 millimeters of mercury, 101,325 pascals, 1 atmosphere. And as I mentioned, you could also do this in English units. So this could be in inches of mercury as well. If you check out the weather, like a weather app or something, you'll often see something like 29.92 inches of mercury, or you might see it on your app as just 29.92 inches. That means inches of mercury. And it's just the same thing. They've just measured this column height. Instead of in millimeters, they've measured this column height in inches. So that is 1 atmosphere in inches of mercury, 29.92. The only other unit that I'm going to expect you to know is the unit of torr. Torr is often used for lower pressures, like when you create a vacuum, it's often measured in torr. And 1 torr is equal to 1 millimeter of mercury. So 760 millimeters of mercury is equal to 760 torr. As I mentioned, often torr will be used when you create a vacuum, when you suck air out and you lower the pressure. They'll often do that in torr. There are plenty of other pressure measurements, pressure units, but in this chapter we're not going to concern ourselves with those other pressure units. So the ones that we need to know, absolutely, you should know what a Pascal is, you should know what a torr is, you should know what an atmosphere is, and you also should know what millimeters of mercury are. If you know those 4 units and how to convert between those, that's everything you'd be expected to know in my class. Using mercury again, we can create a pressure gauge called a manometer. And the way a manometer works is you have some mercury in a tube, you have a tube connected to maybe a high pressure gas, and the high pressure gas forces the mercury to get pushed out of the tube. Okay, this is at a higher pressure than the atmosphere. And because it's at a higher pressure, this will push this column of mercury down. Once again, we can measure the height difference, and this would be in millimeters of mercury. We can measure the height difference, and that will tell us what the pressure is of the gas contained in this high pressure container. So this manometer is one way we can measure pressure. There are a variety of other mechanisms or methods of measuring pressure, but this is kind of a simple one to understand. The other ones are rather more complicated. So in the next video, we're going to take a look at several gas laws which were derived over the last several hundred years. We call the simple gas laws, and then we're going to put them all together in the following video in what's called the ideal gas law. So stick around and we'll see you soon. Thanks. Bye.